huge advantage of 3D printing is the ability to design and print your part as a single unit. So why would you go through the trouble of splitting up your design and printing multiple parts and then assembling them later? The answer is to increase the strength of your parts. I'm Peter, and this is Reinforced. At Markforged, we're all about strong parts and getting the most out of them. Today, I'll walk you through a real-world example, step by step, how to design, print, assemble, and even test multiple parts printed separately in their ideal orientation and joined together so they can be put to use in their strongest possible state. So let's take a look at our example part. This is a mounting plate that's designed to secure a tent pole to the ground. The plate is secured to the ground through these 4 holes, while the tent pole is secured to this boss. This is a common case where the direction of the load is perpendicular to the plane that the part is mounted to. With fused filament fabrication printing, or FFF for short, parts are fabricated layer by layer, which means the X, left to right, and Y axes, front to back, will inherently have more strength than the Z axis, up and down. This is primarily due to the bonds of thermoplastic materials being stronger within the layers are printed than between them. If we printed this as a single part horizontally, the bottom plate would be strong, but the part would fail on the plane with the lowest cross-sectional area when enough load is applied, like this part here. We could turn it on its side and print the part vertically, which would give much more strength to the center boss. However, we've made the part weaker in bending about one of the axes parallel to the printed layers, like this tested part here. This also adds additional print time and support material usage. But if we split this into 2 distinct parts and print them in their ideal orientations, we give them the ability to withstand higher loads when assembled together. Let's hop into CAD and get to work. So we have our mounting plate open in SOLIDWORKS, and we don't want to modify the overall geometry. We only want to modify it so that we can print this as 2 coparts. So first, what I want to do here is create the volume that one of the coparts will occupy. So to start that, I'm just going to make a sketch on this bottom face here of just a rectangle centered at the origin. And I'm going to extrude this so that it's offset about 2 millimeters, just so that we have some material to resist the copart pulling through the other copart. Before completing this, I'm going to uncheck merge result so that these 2 bodies don't get merged together. So you can see now I have 2 bodies, one of the original part and that boss we just made. Next, I'm going to make another sketch on top of this extrusion we just made. I'm going to make that circle co-radial with that boss. And that's just going to be another circle here that's extruded through the rest of the part. And I'm going to only merge this with that body that we just created. So in order to make inserting this copart easier, I'm going to use the chamfer tool and chamfer around these edges at about 8 degrees. So by adding a chamfer, this will make assembly easier and guide the parts together. And next, I'll go to Insert, Features, Intersect, and select our 2 bodies that we have. And hit the Intersect button and unselect that volume we just made. And I'm also going to make sure that I uncheck Merge Result so that these 2 parts don't get combined together. And just like that, we have 2 coparts that are ready to print. So if I hide one, you can see what they look like individually. And for my case, I'm good with these parts as is, but if you want to use an adhesive or want them to be more of a loose fit, you can use the Move Face tool on one of the parts to add more of a clearance between the 2. I'm going to go to Save As and change to Save As an STL, and I'll just call it Mounting Plate 1 and save that. And make sure I only export the selected body, and I'm going to do the same thing for the other copart. So if you're not a Markforged user, just be aware of how your slicer is orienting your parts. If you're a Markforged user using Eiger, you can just go to Import STLs and select your 2 files, or however many coparts you have, and import them separately. And here I'm going to be selecting the optimal orientation like we discussed before. And for this part, it'll be laying flat like this. And for this one, it will be laying in this orientation. Okay, now that we have both of our parts sliced, we can add them to a build and put them together. So we have our parts printed. Let's remove them from the build plate and separate the supports. Once we finish with that, we're ready to assemble. And there's two ways you can assemble parts together. You can use an arbor press by press fitting the parts together, or you could use adhesives. One thing to note with adhesives, you're going to want to do some research on which adhesives work best for your materials. If you're using a Markforged printer with Onyx, we recommend using Loctite 401, Scotch-Weld DP100, or Scotch-Weld DP420. For other common 3D printing materials such as PLA, PETG, and ABS, good candidates include cyanoacrylate adhesives, epoxies, and silicone glues. For today's demonstration, I'm going to be using an arbor press because it's the easiest way to assemble coparts, and I know that this part will only be loaded in one direction. So at the arbor press, I'm going to loosely assemble the parts together, and then I'm going to press down in the middle of the part, joining them together, and then to ensure that everything is seated, I'm going to press down on all four corners. And just like that, our part is done and ready to be put to use. So this small bit of extra effort will be worth it. Don't believe me? Let's test it. We tested 3 different parts, all printed on a Markforged X7 with carbon fiber reinforcement. Part number 1 was printed as a single unit horizontally in Onyx with carbon fiber. Part number 2 was printed as a single unit vertically in Onyx with carbon fiber. And part number 3 was printed as 2 parts in their ideal orientations with Onyx and carbon fiber. And just as expected, coparts reinforced with continuous carbon fiber perform much better than the single parts. The coparts reached a maximum load of 5,747 newtons, or about 1,292 pound-force. That's an 87% improvement over the next best mounting plate printed as a single part with continuous carbon fiber. And that's it, you're done. I hope you found this video helpful. If you have a question, do you want to see us cover a topic you've been dying to learn more about, make sure to leave a comment. If you're interested in seeing some additional example parts and more in-depth testing, check out the open access paper we recently published in the Rapid Prototyping Journal, which is linked in the description of this video. If you want to see more 3D printing tips and tricks, subscribe for monthly videos on 3D printing best practices. Thanks for watching and happy printing.